In this video, we're going to talk about discriminative and generative algorithms. These are two important types of machine learning models. To make it easy for you to understand, we'll start with a story and then discuss how these two types of machine learning work in detail, using popular algorithms as examples. So let's jump right in. Alright, let's dive into our story. Let's imagine we have two alien visitors who have never seen apples and bananas before. We want to observe how they learn to distinguish between these two fruits. The first alien decides to understand these fruits by drawing them. It carefully observes the shape, color, and texture of each fruit and then recreates them on paper. This way, it creates a visual representation or a model of what each fruit looks like. Whenever it sees a new fruit, it refers to these drawings to identify that fruit. This is similar to what we call a generative algorithm in machine learning. The second alien, on the other hand, goes about it differently. Instead of drawing, it starts comparing the features of the fruits. It notices that apples are usually round and red, while bananas are long and yellow. When it's given a new fruit, it doesn't look for a perfect match. Instead, it checks which fruit's features are closer to the new fruit and guesses that it is the same one. This approach is more like what we call a discriminative algorithm in machine learning. So that's the basic idea. These two different approaches will help us understand discriminative and generative algorithms. Moving on, let's formally define our two types of algorithms based on our aliens approach. The first aliens method is a prime example of what we call generative classification. This is where a model learns to generate a representation of each class. It's like learning how an apple or a banana looks and using that knowledge to identify the future instances. In contrast, the second aliens method represents discriminative classification. This model learns to distinguish between classes based on their features. Instead of learning what an apple or banana looks like, it learns the differences between them. It then uses these differences to decide what a new fruit might be. Each approach has its own strengths and weaknesses, and they're used in different scenarios. Now that we've introduced the concepts, let's explore them in more depth. To better grasp these concepts, we're going to discuss specific algorithms that employ these two types of classifications. For discriminative classification, we're looking at logistic regression as an example. And for generative classification, our example will be the naive Bayes algorithm. So, in the realm of discriminative classification, logistic regression creates a decision boundary based on the features of the input. For our fruit example, these features could be color, length, or weight. The algorithm learns patterns from these features and then uses them to classify new fruits. Conversely, the naive Bayes algorithm, which is a generative classification model, tries to understand the distribution of each class in the feature space. Rather than just identifying the differences between classes, it learns how each class distributes in the data. Now, let's go deeper and understand how these algorithms use the strategies to classify new data. With the logistic regression model, we're dealing with features like color, length, and weight of the fruits. The model uses these features to learn patterns and make decisions. For example, it could learn that if a fruit has a yellow color and is longer than 5 inches, there's a high chance it's a banana. This method of creating a decision boundary based on features of examples is the essence of discriminative learning. On the flip side, generative learning, used by the naive Bayes model, attempts to understand the distribution of each class in a multidimensional plane, like a three-dimensional space for our three fruit features. The model tries to visualize where apples and bananas are likely to appear in this space, based on their color, shape, and weight. Now, let's think about some important questions about generative and discriminative models. Questions like, which model needs more data for training? Which one gets affected by missing data? Which model gets impacted by outliers? Which requires more math? And which one tends to overfit? It's important to think about these questions because they affect how you might choose to use these models. For example, a generative model doesn't need a lot of data because it's just trying to understand the basic characteristics of each class. However, a discriminative model needs more data because it's trying to learn the intricate differences between the classes. Thinking about these questions can help you understand these models more deeply and use them more effectively. But don't worry if you're not sure about the answers. We're going to discuss them in detail. So let's look at the first question. Which model needs more data for training? Discriminative models, like logistic regression, generally need more data for training. They learn by identifying differences between classes, so they need a rich and diverse set of examples to do that effectively. The second question is, which one gets affected by missing data? The fact is that both types of models can be affected by missing data. But generative models might be more sensitive because they're trying to capture the overall distribution of the data. Any missing information could skew their understanding of that distribution. Next question is, which model gets impacted by outliers? Again, outliers can affect both models, but discriminative models might be more susceptible. These models focus on boundaries between classes, and an outlier could significantly shift those boundaries. Next question is, which requires more math? In terms of mathematics, generative models like naive Bayes often require more calculations because they involve estimating the distribution of data, which can be computationally intensive. And the last question is, which one tends to overfit? Overfitting can occur in both models, but discriminative models are generally more prone to it. This is because they can become too tuned to the training data, learning even its noise and errors. And now that we know the difference between discriminative and generative machine learning algorithms, let's break down some common examples of each type. So, some of the discriminative algorithms are logistic regression, support vector machines, decision trees, random forests, and gradient boosting machines. Some of the generative algorithms are naive Bayes, Gaussian mixture models, hidden Markov models, latent Dirichlet allocation, and generative adversarial networks. So, to wrap it up, in this video, we've unpacked the world of discriminative and generative models using a simple and engaging story. We've seen how logistic regression in a discriminative model uses distinct features to create decision boundaries, while the generative model, naive Bayes, tries to understand the overall distribution of the data. Understanding the difference between discriminative and generative models give us valuable insight into how generative AI systems operate. Generative models, like the ones used in generative AI, learn the underlying distribution of the training data. This knowledge is then used to generate new data that mirrors the training data. This is why generative AI is so powerful. It can generate new, realistic outputs, such as images, text, and even music, because it understands the world of its training data. In contrast, discriminative models simply learn the boundaries between classes and are primarily used for classification tasks. They can't generate new data because they don't try to understand the underlying distribution of the data, just the differences between classes. By understanding these differences, you can better appreciate the capability and flexibility of generative AI systems. This comprehension could guide you when deciding on which type of AI system would be best suited to your particular project or use case. And by that, we reach the end of section 1 of this course, Traditional Artificial Intelligence. I will see you in section 2, where we discuss Generative Artificial Intelligence.